Hello friends, welcome to the channel. Today we are going to deal with the last part of the chapter atomic structure. Now let us start. First of all, today we have a formula of total number of spectral lines. The formula for total number of spectral lines is n2 minus n1 into n2 minus n1 plus 1 whole divided by 2. This is the formula. Now, if suppose the value of n1 becomes equals to 1, this formula you have heard, if the value of n1 becomes equal to 1, then it gets derived from this formula only, that is n into n minus 1 divided by 2, right? Now, after this, we also have the formula of energy that says the energy in electron volt. Energy in electron volts can be written as 12,400 divided by lambda in angstrom This is also an important formula. If the in a question energy is given in electron volt and wavelength is given in angstrom, then you can very well use this formula. Now many of you must be knowing that the total energy is equal to the negative of kinetic energy. Similar is there in the formula. Total energy is equal to negative of kinetic energy, and also it is equal to potential energy divided by 2. This is the relation. Now, let us start the formulas considering the motion of nucleus. If we consider the motion of nucleus, so there will be slight change in the formula. First of all, see, suppose this is the mass of atom, and this is revolving in orbit, and here is an electron revolving in an orbit, right? The center of mass somewhere here lies, as you must have heard that the center of mass lies near to that of heavier one, the heavier mass. Now let us say that the distance between capital M and small m is small r, and also let me take this distance is r1 and this distance to be r2. Now see, what is capital M? Capital M is the mass of nucleus. The mass of nucleus is capital M. What is small m? Small m is the mass of electron. Small m is the mass of electron. Now, as you can see that small r is equals to r1 plus r2, and also in chapter center of mass you must have heard capital M r1 is equal to small m into r2. So similarly we can write r1 to be equal to mr divided by capital M plus small m, while in r2 it can be capital M into r divided by capital M plus small m. Now you can very easily remember this as the r1. You can see here is r1 and the mass which is away from it is small m, so we will use the formula small m here, while in r2 the mass which is away from r2 is capital M, so we will use capital M here. These were the two formulas. Now let us move forward. See, now moment of inertia can be written as mr1 square plus mr2 square, or the moment of inertia can also be written as capital M small m divided by capital M into capital M plus small m into r square, right? So we can also write this as mu. Mu means reduced mass. This can be written as reduced mass. This is the equation. Now also, let me write some little bit formulas. As angular momentum can be written as I into omega, rotational motion chapter equation. L is equals to I omega, which can be written as nh upon 2 pi, as we studied here. Now, what we can write for I, mu r square into omega is equals to nh upon 2 pi. Now, from here we can derive V is equals to, as you know, the equation V is equals to R into omega. So now the if we consider the motion of nucleus, the new formula of radius and the new formula of energy, the new formula is radius is 0.529 into n square by z, but there is a change into small m by mu in angstrom. And similarly, in energy, that is minus 13.6 electron volts z square by n square into just opposite of this, that is just reciprocal of this, mu by m electron volts. This is the formula of energy. Now let me come to the last concept of the chapter, I can say, that is the recoiling speed of atom on emission of a photon. The recoiling speed of atom on emission of photon. Now see, suppose in the first case we have, this is an atom, and this atom is actually fixed. Now suppose from here an electron is ejected. Let us take this atom of hydrogen atom in the first excited state. Now an electron gets emitted from here with an energy of hc over lambda, which can be written as 10.2 electron volts. Now second case, where let us take this atom, but this time let us take this atom to be free. It is not fixed here. In this case we have taken this atom to be free. Now here also the electron emits with hc over lambda dash. Let us take the wavelength here to be lambda dash. Now let me tell you something. See the values which I'll be using. P1, this is the momentum of photon. P2 will be the momentum of atom, and P1 and P2 will be equal in magnitude. P1 and P2 are equal. Now according to Einstein's energy mass equivalence, E is equals to mc square, and energy can also be written as hc over lambda. So here one c gets cancelled. Mc is equals to h over lambda, that is equals to momentum. P is equals to h over lambda. Lambda is equals to h upon p, right? So now seeing the momentum of a photon. The momentum of photon. See, in the momentum of photon, it is h over lambda dash. Now see, suppose this is an atom which is going this side by velocity v and mass is small m, and an electron gets emitted in the opposite direction with momentum equivalent to h upon lambda dash. Now mv can be written as h upon lambda dash. Let us consider this to be the first equation. Now let me write the conservation of energy. Half mv square plus hc over lambda dash is equals to 10.2 electron volt. As I previously told you, this is for hydrogen atom going on. This is here we have used the conservation of energy, right? Now is for calculation, let us neglect this half mv square, right? Now it will be hc over lambda dash is equal to 10.2 electron volts, right? Now let us consider this to be equation number second. So now from equation 1 and equation 2, Hc over lambda dash is equal to 10.22 electron volt. This is the second equation, while the first equation is mv is equals to h upon lambda dash. From equation 1 and 2, we can write m into vc can be written as equals to 10.2 electron volt. Now comes the formula of velocity. V is equals to 10.2 divided by mc electron volts. So like this, we end the chapter atomic structure. Let's meet in the next video. Thank you.